Have you seen these people who sleep on a bed full of nails? And to make things more dramatic, will have an assistant to hammer on them? Why doesn't it hurt? Or have you wondered why military tanks have these chains? Why don't they just have wheels like any other normal vehicles? Now, these two things might seem unrelated, but they can be answered by using one single concept of pressure. And so in this video, let's explore what pressure is. To understand pressure, let's ask some more questions, but this time a little day-to-day life. For example, when you hammer onto a nail, then it can puncture this wooden board, right? But what if you were to keep the nail this way? And let's say you put the same amount of force. Do you think now it'll be able to puncture through? No, right? It won't. But why? Well, you might say, well, if you want to puncture through it, you need to keep that pointed end over there. But why? Think about this. Let's take another question. If you want to chop a tomato, you can easily do that by using a knife. But instead, let's say you used a finger and you put the same force as before. Now you can't chop it. Again, why? Even though you're putting the same force as before, why can't you chop this time? Well, again, you might say, well, that's because, knife is very sharp and our fingers aren't. And so to cut something or puncture something, it's important that it has to be very sharp or very pointy. But why? Well, let's look at these examples a little bit more carefully. So if you take the hammer example, whether you keep the nail this way or this way, if you bang on this nail with the same force, let's say, then in both these cases, the nail will start putting a force on the board. And if you bang with the same force, then they also put the same force on the board, right? But over here, because it is very pointy, the contact area is so small, and as a result, all the force gets concentrated into that tiny spot, tiny area. But over here, because the contact area is big, much bigger compared to over here, that force gets divided over that large area, and it starts acting over that large area. And as a result, if you now compare the amount of force that appears on the same spot as before, look, that force has reduced significantly because it got divided. And that's why it's harder to puncture through over here. And the same thing will happen in the tomato case as well. When you use a knife and put a force, then all that force gets concentrated into a very tiny area because the knife is very sharp, very tiny area. But because your finger is not so sharp, the base area of your finger is so wide, so large compared to the knife, that entire force gets divided over a large area. And as a result, the amount of force that appears on the same slice of the tomato as before is significantly small. And so it seems that if you want to cut something or if you want to puncture something, then it's not just the force that matters, but that force has to be very concentrated. How concentrated that force is, that's what matters. And that's what we call pressure. Pressure can be thought of as how concentrated your force is. And how do we calculate it? Well, just like over here, we saw that we are basically calculating how much the force gets divided over the area. Mathematically also, pressure P is calculated as the force divided by the area. So in both these cases, when the objects are very sharp, the contact area is very small. And so the pressure that they experience is large. And that's why they're able to cut and puncture through. On the other hand, if the contact area is very large, even though you put the same force, notice the pressure becomes very small. So in these cases, the pressure was very small, and that's why it was not able to cut through. So to cut something or to puncture something, you need to have high pressure, not just the force, but high pressure. The force has to be very concentrated. Okay, now before we proceed, let's quickly look at its units. What do you think will be the units of pressure? Can you pause the video and think about this for a while? All right. Well, force has units of newtons. And area, the standard unit, is meter square. And so pressure is calculated in newtons per meter square, which means it tells us how many newtons of force is acting for every meter square of area. And Newton per meter square is also often called Pascal, named after the French scientist. But don't worry too much about the units right now because we will solve problems in another video, so it'll be more clear over there. Anyways, now let's see if we can use this concept to answer our original question. So if we come back to the bed of nails example, usually we look at that bed and say, oh my God, there are so many pointy nails. Won't it hurt? But the point is, because there are so many nails, it doesn't hurt. I mean, if you were to sleep on such a bed, and I don't encourage that, it is a little dangerous, so please don't try this at home. But if someone were to sleep on this bed made of so many nails, then that bed has to support his or her weight, so it has to push up on that person. But because there are so many nails, that force gets divided over all the needles, and as a result, the force acting on each part of that person's body would be pretty small, which means the pressure over here is pretty low. But imagine what would have happened if there were less nails. Now, one might think less nails means better, right? Less pointy surfaces, but it's actually worse, because if there are less nails, then the amount of force is the same, but now that force gets concentrated over these fewer nails, and as a result, the pressure becomes much higher, and that could really hurt. Okay, what about the tank? Can you now pause the video and think about why a chain is needed for this tank? Tanks are very heavy, that's the clue. Did you get it? Well, it's to lower the pressure on the ground. Let's see how. If we were to zoom in close to the wheels, imagine if there was no chain over here. Then the wheels would be directly touching the ground, right? So what? Well, if the wheels are directly touching the ground, look at how tiny the contact areas are. And so all the weight of that tank, that huge force, will now be concentrated in these tiny spots, just like a needle. And as a result, there will be a very high pressure on the ground, and that pressure could actually kind of break that ground. And so if there was no chain, it's a good chance that the tank would actually get a little buried under the ground, and it'll be pretty hard for it to move. But if you put a chain like that, then when you put a chain over here, now the force is still the same, okay, because the weight of the tank has not changed. But look at the contact area. Ooh, that increases significantly. There's a huge contact area now. The force gets divided, and as a result, the pressure gets lowered. That's the whole idea. Now, before we wind up, one small detail that I missed out, just a naming thing, is that we said pressure is force over area, right? But what's important is that that force that we are applying needs to be perpendicular to the surface. It has to be perpendicular to the surface. Only then you'll press against that surface and you'll apply pressure. Imagine if you had hammered the nail this way, applying a force in this direction somehow, let's say. Then what would happen? It will not apply any pressure, right? The nail will just slide on its surface. Now, regardless of how concentrated that force is, it'll apply absolutely no pressure, isn't it? And so pressure only makes sense when you're applying force perpendicular to that area, perpendicular to that surface, okay? And your textbooks give a name to this perpendicular force. I don't know why, but whenever the force is perpendicular to the surface, your textbooks give a name to it, and it's often called thrust. And so you might see sometimes in your textbook written pressure as thrust over area, but don't worry too much about that. Thrust is nothing but the force which is perpendicular to the surface. And that's pretty much it. So what did we learn in this video? We saw whether your force can cut something or puncture something depends upon how concentrated it is. And that's what we call pressure. And because pressure is all about calculating how much the force gets divided over a given area, we calculate it that way. We calculate it as force divided by the area. And a small detail is that when you're applying pressure, your force must always be perpendicular to that surface. Just to distinguish that from any other force, just to tell that that force needs to be perpendicular, some textbooks will call that perpendicular force as thrust. And from this, we could work out its units as well. And now you finally know why sleeping on your favorite pillow is so comfortable, but it is so uncomfortable to sleep on a hard brick.